this is the Linux terminal, and I have everything pushed into the GitLab, and that is synchronized in this instance as well. You can see the same source code is available here. So first of all, I'll change my directory to deployment. So in order to start off with this, I have to create a cluster. So I have to create this cluster in my environment. So that is what I am going to do, and I'll be creating a cluster with 4 worker nodes and 1 control plane node. So I'll be doing that now, and there is a shell script I written for that, and I'm going to run it. Yeah. So this script will simply delete the existing cluster, and it will create a brand new cluster for us for the testing purpose. So you can see now the existing cluster is deleting. So I have earlier I have created the same cluster. So you can see that is being deleted now, and it will start creating the cluster for us in a minute. And also there are 2 containers running for the database purpose. So that is a MongoDB called MainDB, which keeps all the information related to the microservices, and there is another separate database for the AgentDB, and which will keep all the log information for the machine learning process. So now I think it will take some time to complete this cluster creation. So I'll time to time I have to pause the video, and because this entire process is really time consuming, so I'll be pausing and resuming time to time. Okay, now we can see the cluster is up and running. It's ready now. So you can see all the worker nodes and control plane is up and running. So now we need to actually monitor this cluster. So in order to do that, the Kubernetes provides us kind of a nice dashboard. So I have to start the dashboard. So that also I'm having sort of a bash script. So I'm going to run it, and yeah, so that has been created, but it takes a little while to start the UI, but I'll try to hit it now and see. Yeah, so still it's not up and running, so we can wait for a while, and we have to save this token in order to log into that dashboard. So I'm going to keep it. Yeah. Okay, so while that is up and running, we can start on the deployment part. So I'm going to deploy all the microservices into the created cluster now. So for that also I'll be having a separate shell script. I'm going to run that one. Yeah, so to deploy all 4 microservices into the cluster, it takes a few minutes. So again, I'll be pausing the video, and will be resume at the time everything is up and running. Okay, now we can see all our services are successfully deployed into the cluster. So now our Kubernetes dashboard also up and running, so we can monitor the cluster and see all the pods running. Yeah, here we can see all services are running now. So each and every service having 2 pods in it. So in order to test this services, I'll try to hit one of the health endpoint of one of the microservice, the order microservice. So I'm hit send, and you can see it's returning us 200 response. Okay, so now I think everything is set for the testing. So we can then try to put some load and see how this model training part is happening. Okay, so before we start testing, actually we have to start some few other components. As I mentioned earlier, now we have to I'll try to change my directory. Yeah, so there is a mining component, we have to run it. So I'm going to run it. Now it's up and running, and so we have to start the Python component as well in order to generate the model and do the predictions. So you can see under this directory there is a file called model.pkl. So that is the model. So I have serialized that into a file named model. So, and also all the data, I mean the sample data will be accumulating in this particular folder. So if you go here, you can see data.csv is the file which has all these records. So you can see the timestamp here. It's March 16, 22 something. So once I run the system, you can see this is getting updated. Okay, so before that I'll start the system component. Okay, now it is up and running. So we have now all these things ready. So we have the Python component running, and we have the mining services running, and we have all these microservices deployed into the cluster. So now in order to test this, I'm trying to use my test engine, the load engine. So in order to trigger a load, so there is a REST endpoint where we can set some load information. So what is the amount of load that you need to generate and all that, then we can simply hit that endpoint, then that will start the load test. So here we can specify a few things like what is the minimum and maximum number of pods and number of retries, like different things, and this is pretty important, number of threads. So this is the parallel execution, and in each thread we have specified to made 20 requests. So the entire load will be then 20 into 10. So yeah, these are some other configurations, and this is something called load repeats. So how many times you have to repeat the load. I mean each repeat it will increases the load. So likewise. So yeah, so that's pretty much of it, and I'll be setting this to false because I need to performance test this. We will be scaling the system and push the load. Again, scaling the system, push the load. For example, it will start from 2 pods and push some load, and scale it to 3 pods, push some load again to 4 pods. Likewise, it circulate. So by doing that, we can simply get some considerable amount of samples to train the model. Okay, I think we are good to start this. I'll try to see the logs here. Okay, so I'm gonna hit this now. Right, so you can see starting the load test, and its first cycle is running now. So if you go back here, For the first time it runs with two pods. It won't do any changes to the cluster, but while the testing is running, we can observe the scale up and scale down is happening. So I'll wait until it's reach into the three pods load. So then I'll pause the video and come back again. Yeah, we can see now it has made 200 requests for the first cycle with two number of pods. Yeah, so it runs because now it comes to 3 pods, right? So you can see the scaling is happening. Unfortunately it logged out. I'll log it again. Yeah, you can see the scaling is happening now. All the services are requesting to scale up to 3 pods. So this take a while, and you can see until the scaling is completed, performance test is waiting. So once it is done, then it will start loading again. So this will happen until it goes up to 4 pods, and again it come back 4, 3, up to 2. So this cycle we can repeat up to any extent, so as we need. So for this I scheduled it only for one cycle. But you can see the scaling is completed. Now it starts loading. So like this, the performance test will run. So I will pause the video again now, and we'll resume once the test is completed. So still the testing is running. We can observe that the load is increasing. So in previous cycle it was 200 requests for one load, but now it's increased up to 600 in the second run. So likewise, each cycle it increases the load as per setting. So yeah, and also we can see a log that adjust execution is blocked and remodel execution is blocked. That because while running a load test, there is a lock running, and which this is not allowing to auto scale or remodel, just to avoid interference to this load test. Now the test has reached to the its last stage. Now it runs the final 600 requests. So then the test is going to be completed. Yeah, so you can see the load test has been completed. So it has created the CSVs and all the necessary information. So now in the next cycle it will do the auto scaler. If you wait for a while, we can observe that as well. Yeah, you can see now the auto scaling part is happening. So it suggested to have only 2 pods for all the nodes at this moment with the load it specifies. So we can try to put some different load and see how the scaling is happening. Okay, so before that probably I can show that new model creation. Yeah, you can see now the it's trying to remodel. So the model has been updated now. So the model cycle was running, and also if I try to show that data creation part, you can see now this is updated in the timestamp. You can see March 17, 928. So we just updated this CSV and it created the log file as well. Yeah, so those are the main things from the testing perspective. So I mean the load testing and model creation perspective. So then the remaining thing is to uh, put some actual load and see how the auto scaling is happening. Okay, so as the final part of the demonstration, so I'm trying to push some actual load to the system and see how the model is predicting to scale the number of pods in the cluster. So for that one, I'll be using the same REST endpoint. So in order to put some actual load, I have to set this flag to true, and I'll be using the same load. I'm not going to change it, so I'll be running it for 2 times, and yeah, so I think we are good to run sort of a testing now. You can see now it is defaulted again back to 2 because now we don't see any load in the cluster, so then it's defaulting to 2 number of pods for each and every service. So right now I'm gonna hit this load here. You can see now the load is running. So at the next cycle it will detect the load change and it will try to adjust the cluster based on that. Yeah, you can see now it has been changed and it's suggesting 4 pods for stock and 4 for shipment and 3 for order and 4 for payment. So now you can see the cluster is also adjusting based on that. I go back here and still it's scaling. There you can see the scaling is completed, but now since we don't have any load in the system, so it will cool down and set it back to the minimum number of nodes. You can see the cluster has been reset back to the 2 pods because we don't have load there. Yeah, so I think that covers pretty much. I know it's a little bit disturbing because it's taking some time to demonstrate the entire flow. If I could have deployed this in sort of a cloud environment with enough hardware configuration, then we should get much better results. But I think in my local it runs pretty well. So yeah, that's all about the demonstration part. So thank you very much.